All right, everybody, here are the notes for 6.2, which is writing linear equations from tables. Now, hopefully that sounds familiar to you. This is actually stuff that we did in Module 5 that we even did on the Module 5 test, where I gave you a table and then you had to write the equation for it. Now, what we're going to do today is going to be something just a little bit different for part of this. Okay, so just kind of have to bear with me. So there's nothing new to learn, which is why we're jumping right into example A. Or I shouldn't say nothing new to learn, nothing new to define. But all right, here we go. Example A says the table shows the temperature of a fish tank during an experiment. Graph the data and then find the slope and the y-intercept from the graph. Then write the equation for the graph in slope-intercept form. So we're going to take this data and put it into the table. Okay, now when we do that though, like the first point is 0, 82, over 0 and up 82. So if I zoom in over here on my graph, if you look at the y-axis, you can see that these numbers are going by tens, right? They're going by tens. So the problem here is this: if I go over 0 and up 82, I'm going to have to estimate as best I can. Okay, so that's the bad part about this graph. Now, 1 and 80, that one will work nice. But other than that, we're going to have to estimate, which makes this a little bit tougher to work with. So 2 and 78 would be there. And then last one, oh, I forgot. This is a typo here. This should be 76. So 3 and 76 would be about right there. So we'll just have to do, like I said, just do the best we can with that. Now, the problem with that, and again, the problem is not that we can't graph it. We can graph it. It's not going to be the best, but we can do the best we can. It says find the slope and the y-intercept from the graph. Okay, so if I go to the graph now and try to do rise over run with those points, that's going to be, almost impossible to do. Okay, so this graph, even though we wrote it, we really can't use it anymore. Okay, so we're going to find the slope and the y-intercept from the table just using this. Okay, so how do you find the slope from a table? That is the same thing we've been doing before. Okay, which is using the slope formula. y2 minus y1 over x2 minus x1. So take any two y values and their x values and subtract them. So I'm going to do 82 minus 80 over 0 minus 1. Okay, again, like I said, y values on top, x values on the bottom. Make sure you stay in the same order. So that'll give me 2 over negative 1, which is negative 2. Okay, second thing is the y-intercept. Now, if you look at the table and think back to what we did like on the test in Module 5, we always would use the pattern of the table to find the y-intercept. But we don't need to do that. So if you look at what I just highlighted, we already have where x is 0, that y is 82, which is the y-intercept. So that means our equation is y equals negative 2x plus 82. Okay, so that one actually works out pretty good and is a little bit easier because of what they give us. So, and again, too, I like to talk about, or I'm just going to kind of say what this means in this situation. So remember, this is a fish tank and the temperature. So what's happening is this fish tank is starting at 82 degrees, and every hour it is decreasing. The temperature is decreasing by 2 degrees according to this. Okay, so the your turn problem, excuse me, very similar to that. You can go ahead and give that one a shot on your own. I'm going to do example B. Okay, and example B says a salesperson receives a weekly salary plus a commission for each computer sold. The table shows the total pay Y and the number of computers sold X. Write an equation in slope-intercept form to represent the situation. So, a weekly salary plus a commission. I'm going to make sure we understand that what a commission is. Okay, so what this means is this person comes in, if they come into work every day or whatever, they get a weekly salary. Or in other words, every week they get, I don't know how much, but they get so much money. They get no matter what. The commission means for every computer that they sell, they get an additional amount of money. Okay, so when you're looking at the table and it says 4 computers sold in the total pay, that means if you sell 4 computers, you get $550 for the week. That's your weekly salary plus any commission you get. Same thing for 6 computers, you get $700. 8, you get 850. 10 is 1,000. Okay, so obviously the more you sell, the more money you're going to make. So let's find the equation of this table. Same thing as up above, y2 minus y1 over x2 minus x1. So I'm going to do 700 minus 550 over 6 minus 4, making sure I keep things in order. 700 minus 550 is 150, 6 minus 4 is 2, and 150 over 2 is 75. And 75, what? So that number right there is $75. That's how much money you get per computer sold. Okay? So I know right now my equation is going to be y equals 75x plus b. Okay, I just put a b there for now. I don't know what it is yet. Obviously, we're going to find it. So normally, what we would do is we would go to the table, excuse me, and we would use the pattern of the table and find where, where x is 0, which is exactly what we talked about up above. It's exactly what we did in Module 5, right? It works really nice. Okay, but even though this one does have a nice pattern and it would get us back to 0, I want to show you a different way to do it because that's not always going to be the case. You're not always going to have a nice pattern, or maybe the numbers aren't just very nice to work with. So remember what these things mean, and I'm actually going to jump back up here real quick. Remember what these tables mean. So I have my equation up here that we found of negative 2x plus 82, right? So that means in my table, 1 and 80 should work. Or in other words, if I put 1 in for x, I better get 80 for y. If I put 2 in for x, I better get 78. If I put 3 in, I better get 76, right? Those numbers have to work, and if you plug them in, they will. If I put 1 in for x, I will get 80. Okay, so that's what we're going to use that idea right here to find this b value. Okay, so here's what I'm going to do. I'm going to take any one of these points here, any one of those 4. It doesn't matter which one I pick. Okay, but like I've always done, I'm kind of lazy. I like to use numbers that are easy to work with, so I'm going to pick the first one because that's the numbers are the smallest. And I'm just going to plug both of those numbers in. I'm going to put 4 in for x, and I'm going to put 550 in for y. And I just kind of realized I'm going to run out of space. So I'm going to put 550 in for y, and I'm going to put 4 in for x, and I still have my plus b. I don't know what that is yet, but now look at what I have. I have an equation that has just one thing that we don't know. So now we're going to go back to like 6th and 7th grade a little bit, and we're going to solve this algebra equation. So if I do that, the first thing I see that I can do is, is I can take 75 times 4, which, make sure you have a calculator with you. 75 times 4 is 300. Still got my plus b. This is still 550. And then now all I'm going to do is, how would I get b? How would I get b by itself? So I have that positive 300. How would I get rid of that and move it to the other side? Remember, we would just subtract 300 there. So that would give me 550 minus 300 is 250. So right there I solved that equation and found out that b is 250. So my equation is 75x plus 250. Okay, and again, if I would have put in 6 for x and 700 for y, or 8 for x and 850 for y, or 10 for x and 1,000 for y, I still would have gotten 250. Okay, so that tells me I'm getting $75 per computer and a weekly salary of $250. Another thing I'd like to do real quick, without writing it down, I just usually use my calculator, is I take like the next one and I plug it in and see. So if I put 6 in for x, do I actually get 700 for my answer? Okay, so if I do 6 times 75, what is wrong with my calculator? 75 times 6 plus, what is it, plus 250? I got 700, which, yes, good. I got 700, which was my y value, so I know I'm correct. Okay? So there's one more problem here on the your turn. Now, this table, if you look at it really quick, again, this table does have a nice pattern, so you don't have to plug that in. Okay? Example C, I crossed off. We're not going to do that one. We've seen enough. So I want to show you one more example of this thing that I did here. And so I'm actually going to go to the 6.2 assignment for this and show you that. And in the 6.2 assignment, all it is just a bunch of tables. Okay, no word problems. We've done enough of those to do that for a little while. But all of these, tables, I kind of purposely made them so that there's not a nice pattern with them, so you have to do the other way. So let's find the equation in slope-intercept form for this table. So the first thing is slope again, which again, this part, remember, this is not new. So I'm going to do 9 minus 1 over 3 minus 1, which is 8 over 2. 8 over 2 is 4. So again, my slope is 4, so I know my equation is y equals 4x plus b. Now I'm going to take any one of those points. And just to kind of show you, I usually pick the smallest one. I'm just going to pick something else. I'm going to pick this middle one instead. Just to show you it really doesn't matter. So I'm going to put 6 in for x. I'm going to put 21 in for y. 6, and did I put the right thing in there? Yeah. Sorry, excuse me again. All right, so now I just got to solve this equation. So first thing would be 4 times 6 is 24. And then now I just got to get rid of that number on that side to get b by itself. So it's a positive 24, so I'm going to subtract it. Remember, if it would have been a negative, I would have added it to both sides to get rid of it. So that gives me -3 for my b value. So my equation is y equals 4x minus 3 because that was a -3. And again, just to double check, like if I put like 3 and 9, if I put 3 in for x, I better get 9 for an answer. 4 times 3 is 12. 12 minus 3 is 9. I know I got it right. Okay? So on this one too, if you look at this table, there is no, there's not a good pattern to it, so I can't use the pattern to go back to 0. And a lot of these tables are going to be that same way, or I'm going to have to plug it in, which I know you might be saying, oh, it takes more time or more work. It does take maybe a little bit more work, but this method works every single time. Okay, so the bad part about the using the pattern method is it doesn't always work. This method right here, I don't care if I have a pattern or not. I can do this every single time on any table that I'm given, and it's going to work. Okay? All right, so don't forget to try to finish up these 2 your turn problems in the notes packet, and then the 6.2 assignment, should be the next thing that is on the list to do. All right, as always, let me know if you need any help.